Hello, everybody. I'm going to continue what Andrew was just talking about, IPMX, and we're going to look at a few pictures and look at some utility of IPMX, and hopefully some of the content will match the question that this gentleman asked about mixing different things as well. Let's start with the world we're coming from. It's been a pretty trivial problem to mix equipment of different types if we needed to. Um, if you had a SDI based production switcher and you wanted to bring devices that were HDMI based, yeah, there were mini converters that could handle the job of converting. No skills required, very cost effective, very good performance, no problem. So this has been pretty comfortable. We've been able to mix assets like studio equipment and production equipment with AV routing and signal management equipment and PC equipment without a great deal of difficulty. So we're going to look at these three asset buckets, okay? In professional equipment was pretty typical to find a lot of SDI. Think of your presentation switchers and vision mixers and professional cameras and this type of stuff. When you think of your AV routing and signal management, this is your Crestron World or Extron and these types of products that are really designed to have a good routing interface for users to be able to take a source and send it to a particular display in a conference room or hit some speakers and route whatever they wanted to wherever they wanted. And then the biggest asset class in most organizations is their IT department, their PCs and their mobile devices, handhelds, tablets, phones, etc. So there's been some connectivity between these things through those types of mini converters when necessary. And it hasn't been that hard to go between one asset class and the other. The problem we have is that now that each of these asset classes are migrating to an IP equivalent to migrate their capabilities from the current generation of SDI to either NDI or 2110 for the professional and studio equipment, or a variety of different AV over IP standards in the AV routing and signal management arena, or the IT stuff is going to remain what it is for audio and video. You have processing blocks already available on your phones or in your PCs, and it's not going to change. You're going to use H.264 and HEVC or whatever your IT infrastructure is providing to handle the audio and video. If you were watching audio and video on your phone and it was being decoded in software on the CPU, your battery life would be about 12 minutes. But you could watch a whole movie on your phone. 3 hours later, you still have some battery left over. Why? Because the processing blocks in your devices have really power optimized acceleration for audio and video. And so those formats are going to remain respected in this category of product, and that's not going to change. But now I have a new problem. It's been pretty trivial to go from HDMI to SDI or HD-based-T to HDMI or DisplayPort to HDMI or whatever. With all of these new IP-based solutions being introduced to the market, it's a little bit of a question mark for people. How do I connect these different asset buckets to each other? How am I going to do that if they're all doing different audio and video formats or using different protocols or are available differently on a network or support different bandwidth levels, or some use PTP and some don't? Okay, so what Andy was talking about in the presentation just before mine is about how IPMX is designed to deal with problems like this. So IPMX is attempting to restore the link between your professional equipment, your AV routing equipment, and your IT department. And also, because IPMX is open specifications and can be used by any solution provider, there's also a lot of work being done by organizations to create bridge points with other media and protocols as well, so that things like HD-based-T or NDI or other things can be brought into environments on IPMX networks. So let's look at a few examples. Here's an example of a category of product that is rapidly emerging for support with IPMX. Displays, especially the professional end of displays. Why are display companies so interested in IPMX? Well, put it simply, they've been looking for an IP input on their display solutions for quite some time, and IPMX checks a few boxes as far as being able to sell their displays in a variety of different use cases and environments. When a display, which is an IPMX receiver, is on a network, it could operate in a really rich variety of ways. That display, when you put it on a 2110 network, will lock to the PTP of a 2110 environment and will support the -20 or -22 media that you're trying to feed the display. If you're taking the same display and you're putting it on a rental and staging application in Pro AV, maybe you need sync for your event, but spinning up a synchronization environment for a 10-day event, it may be a little bit involved to create a SIMT 2110 environment to do a build up and tear it down again type of event. So there are additional synchronization profiles available in IPMX that let you achieve synchronization, but with the ability to use standard switches, and where the PTP level of intensity is maybe line accurate PTP instead of pixel accurate PTP. So there are some additional options where you can create a very nice sync environment, maintain a very low latency, but have a usability and an installation a property that makes it attractive for that rental and staging area. And then that same display, if you put it in digital signage or a control room or other applications, you may not require PTP at all. What about media types? Well, IPMX, like SIMT 2110, supports more than one media profile. There's support for stuff compatible with -20. There's support for stuff compatible with -22. And there's additional media profiles that have been added by the VSF in TR10. This includes variable bitrate codecs. So the -22 in SIMT 2110 is constant bitrate. And the codec options that are available with -22 are limited to that profile of codec. The VSF added VBR codecs to IPMX to enable the use of alternative mezzanine codecs or H.264 and HEVC and a broader palette of choices. With audio, routing AES67 audio to a display that has speaker capabilities, this is a very nice capability of IPMX as well. If you have a Dante microphone or an AES67 source, you can pick up the media from an IPMX receiver display and be able to hear the sound for that as well. So there's a lot of attractive characteristics, a lot of adoption. The LED wall tile processor companies are adopting SIMT 2110 and IPMX. They're using 2110 for virtual production. They're using no PTP for their control rooms and digital signage, and they're using IPMX with sync for their rental and staging. There's a few SDM modules and converters that are also now attaching themselves to projectors and commercial displays as well. Now, there was a question from this gentleman in the previous presentation. I'm going to provide a for instance scenario here that might be interesting. Here I'm mixing on the red network here a boundary clock PTP switch. This is a completely synchronized SIMT 2110 network. I have SIMT 2110 sources, compatible switch, production equipment. On this blue network, this is a regular switch. This is not a boundary clock switch, but I can connect this switch to this switch. With the types of displays that I just described that are IPMX enabled, these displays can receive content from IPMX sources on the blue network, and they can also receive content from the red sources on the red network here. So the content from this camera can be displayed on this display. Whatever's on this device on the blue network can also be displayed on this display. That portability of content, the media compatibility with 2110 is exploited here. And the fact that IPMX could live on either this type of network or this type of network is exploited here. So there is new design elements that are powered by the additions to 2110 that IPMX did. Here's another eye chart here. What we have here is an illustration of some of the things that are in IPMX for utility. Let's say here we're showing an LED wall, and there's some things that are natively compatible with LED walls that support 2110. We can grab a 2110-20 uncompressed source, or we could grab a baseband source and convert it to -20, or we could use an IPMX uncompressed source. If the LED tile processor supports IPMX in 2110, it could receive those two media types natively. What if I want to show something that is not in the same media type? Well, because of the properties of IPMX, there is a new category of equipment that is emerging. There are several organizations building IP to IP transcoding gateway products. Some are simple gateways and some are bulk gateways. An example of a simple gateway would be you have a network of devices that are all compatible media-wise, but you want to introduce one element on that network that uses a different media profile. You can adapt it so that it will fit on that network and the media will match. Or a bulk transcoder would be useful if you wanted to convert 50 streams of one type to 50 streams of another type. And these type of IP to IP transcoding devices deal with not only media conversions like uncompressed to compressed or codec A to codec B, but they could also deal with protocol conversions. There's already one company, for example, that is doing NDI with the SpeedHQ codec to IPMX and vice versa. So you can do protocol conversions as well. So that would mean taking an NDI camera. Where's NDI here? Oh, I don't have it. Other media. So you could take an NDI camera, put it on an IPMX network, convert it to something that a device that's IPMX powered can recognize, and it's now an available source. Another aspect of IPMX, you see the little key lock here. All of these IPMX sources and the IPMX destination in this picture, that key lock represents an additional aspect that was added to the VSF TR10 documentation, which is the privacy encryption protocol. So one of the things that IPMX needed to deal with in order to deal with HDCP protected content between brands and between product types, the HDCP key exchange protocol was developed. And this is a protocol that allows different products to exchange keys to support protected content encryption in a common way. Because that mechanism was already done for HDCP, the VSF took it further and added the privacy encryption protocol, which instead of using the HDCP keys in the sources and destinations, you can provide organizations with the ability to put in their private keys. So let's say a bank or a government or a school, the IT administrator might want to determine which of my encoders I want to send to which of my decoders, and I want to prevent my decoder from receiving content from a different encoder that is not sharing the same privacy key. So the ability to load privacy keys means a tremendous amount of control over encryption, even between competing brands. And this is something that no other protocol is doing. This is exclusive to IPMX. Is security between different product types from different brands using the privacy exchange protocol. It's a very, very useful feature. You see the Las Vegas sphere? That's a 2110 environment. I can tell you one thing that's keeping some people up at night is if somebody gets in to that network and puts something on the network that is being displayed on the sphere that you can see from an airplane, that's a really dangerous hoax. It could really wreak havoc on the popularity of that type of solution. So people are seeking actively ways to control what can send content to what, and the privacy encryption protocol is the only thing that achieves that between different brands from different manufacturers. There's a couple of things in yellow here. These are not yet available, but they're coming online in 2024. They've already been submitted to the VSF as a specification for handling USB over IPMX and H.264 and HEVC. So these are going to appear in 2024. The rest of the stuff here is already supported. So in summary, Many sources could be natively transmitted or converted using IPMX. IP to IP gateways could help deal with media, protocol, and timing conversions when needed. Different types of networking conditions, either pixel accurate PTP like a 2110 environment, or a line accurate or a frame accurate network. If you just want to synchronize 4 monitors and take a content and display it on a mini video wall, and you want to use PTP to make sure that the refresh of all of the monitors is the same, or networks with no PTP. And then the privacy encryption protocol and the HTTP key exchange protocol. These are some of the useful things of IPMX that really help bridge your media from one thing to another. Here's another picture. Let's go back to that previous discussion about bridging assets from one thing to another. Here you have NDI. You have your NDI sources. NDI was really, really successful and is growing because it does one thing really well. It gets rid of the friction of an HDMI capture dongle or a capture card. It lets you see a camera in a PC and add it to your PC-based workflow very, very conveniently. And the 3 things that were required for that to happen is use the media that's available in the cameras without requiring the cameras to adopt a special codec or whatever. You provide a frictionless software on a PC that could let you see that camera and decode it and make it available to the PC, and then provide a mini driver that lets you hook up that NDI camera to your favorite application, so the G-Streamer hookup or direct show filter or whatever. Those 3 ingredients made NDI very, very, very easy to use and bringing NDI sources into PC for management. What gets the content to the speakers or the screens that you're trying to hit is usually a function of the software on your PC. It's usually Microsoft Teams or Zoom or whatever favorite application you're using that handles the job from that point. IPMX can be used with NDI sources that are converted to IPMX networks, or the same features of NDI can also be supported by IPMX, where you can bring IPMX sources into PCs. There are companies that offer mini drivers that do the G-Streamer and direct show conversions. The media support for H.264 and HEVC and JPEG XS that could run on CPU or GPU blocks or CPU blocks, that's available. And IPMX can also do the same thing and use Zoom or Teams or YouTube or whatever to distribute content. But the output, the network output of this PC can also be a valid IPMX source to a bunch of receivers like those displays that we just showed in the previous slides. You can hit those IPMX displays with a native IP stream, and you could use an AV routing solution to conveniently route your IPMX to that screen or that speaker, or do the AV signal management part really conveniently. So I urge you to not think of IPMX as IPMX or 2110. I urge you to think of them as IPMX and 2110. And I urge you to not think of other protocols like NDI as a complete alternative to IPMX, but rather that with the emergence of IP to IP gateways and protocol and media converters, that these elements can be shared. So IPMX belongs to no one, and it belongs to everyone. So there are organizations that are leveraging the best of everything that's in the market and creating useful systems and useful networks. So is that it? Oh, Andy touched on this. I'm just going to show it in a different picture. What Andy was talking about is this was the picture last year where an IPMX sender could send in a PTP network. If this was receiving a Genlock source from an SDI source and it was an IPMX converter, on a PTP network could feed 2110 receivers and IPMX receivers, but added the capability that if you were using a network with no PTP, that you can also hit an IPMX receiver and this would also work. What we added in the last year is the ability to document or have a profile in your IPMX sender that can deal with an asynchronous source and correct it so that it could feed IPMX, SIM2110, and AS67 receivers with a PTP network. So these types of senders will be a valid sender to all of these types of products on either of these types of networks. And this type of sender will work when it has a Genlock source on all of these receivers on a PTP network, or if it's an asynchronous source, it can be routed on a regular network. It can be received on a IPMX receiver, and then, as Andy said, some 2110 products will support that, some will not. That's a little bit harder to determine. But what we want to do with the labeling system is make it clear that this type of sender will always work with all of these combinations. So it's going to be a little bit clearer as a map to help people figure out what will have compatibility. So I think that's it.